Hello everyone, let's solve another math problem. Suppose f is a function that satisfies the equation f of x plus y is equal to f of x plus f of y plus x squared y plus xy squared for all real numbers x and y. Suppose also that the limit of x to 0 of f of x divided by x is equal to 1. Find f of 0, f prime of 0, and f prime of x. Okay, so that's an interesting identity. And let me tell you now what I'm thinking here. Finding f of 0 won't be too difficult because we can just plug 0 in for both x and y here, and we should be able to solve for things. And then when it comes to derivatives, remember that in the definition of a derivative, you have a difference between, the numerator looks like f of x plus h minus f of x. Well, when it comes to the f of x plus h, we might be able to use this identity here to make a simplification. Okay. So this is the one identity we're given. We're also given that the limit of x to 0 of f of x divided by x is equal to 1. So this is all stuff that's given. So the first thing we're asked to compute here is f of 0. Well, this is equal to f of 0 plus 0, right? And now I'm just going to use the identity here where both x and y are equal to 0. So this is f of 0 plus f of 0. And both of these will just be 0. So I have f of 0 is equal to 2 f of 0. And this implies that f of 0 is equal to 0. Okay, great. That's the first part done. Second part wants us to compute f prime 0. Okay, well, this is equal to a limit as h approaches 0 of f of 0 plus h minus f of 0 divided by h. And this is equal to a limit as h approaches 0 of, I don't need to use the identity here. We know that f of 0 is 0, okay? And the limit we have here is identical to the limit that we're given in this original property here. So this is just going to be equal to 1. Okay, so I've got that f prime of 0 is equal to 1. Okay. And the last part of the question asks us to find f prime of x. Okay, so again, I'm just going to write this as the definition like that. Now I'm going to substitute f of x plus h. I'm going to use the identity that we're given here. So I have a limit as h goes to 0 of f of x plus f of h plus x squared h plus x h squared minus f of x all divided by h. Okay, f of x cancels, so I end up with f of h. I'll even do some of the simplification here. I'll write it as 3 different terms. Like this. Okay. So what have I done here? I've canceled the f of x. This f of h just sort of carries over. And I've written these as 3 separate terms, each divided by h. So I have f of h divided by h. I have x squared times h divided by h, but that just gives me x squared. And I have x h squared divided by h, that just gives me xh. And, well, I know the limit of this thing as h goes to 0, it's equal to 1. This thing doesn't depend on h, so its limit will just be x squared. And this thing, as h goes to 0, has a limit of 0. So I end up here with 1 plus x squared. Yeah, that was a pretty cool question overall. The second that I read the question, I wasn't really quite sure how I was going to approach this. I kind of thought that using this identity would make things a lot more complicated than it actually does. You see identities like this a lot when you're doing contest type math questions, and those can be a lot more complicated than what you find in a calculus exercise. But as soon as I realized that most of what we're being asked about is computing derivatives, well, if you remember the definition of a derivative in terms of a limit, you know that you have to evaluate the function f at a sum of two numbers. So x plus h is typically the notation that's used. And so that naturally leads itself to using an identity like this. And not only that, I kind of saw immediately that we were going to get a cancellation of the f of x term. I wasn't exactly sure how things were going to fall together for the rest of this, but the fact that everything was given in terms of polynomials in x and h meant that the limits were quite easy to evaluate. Right, so if I have anything more to say about this, or if I find any kind of mistake, I'll put it down in the description. Thanks for watching.